Welcome to Building Heavy-Duty Retaining Walls with Risi Stone. We'll jump right into the presentation by getting to know who Risi Stone is.
So Risi Stone was started by Angelo and Tony Risi in the 60s. They owned a plant in Gormley, Ontario, where they manufactured concrete products, one of them being a 2x2 patio slab, where they came up with the idea of putting a tongue and groove on it, splitting it in half so they could stack them up. And that was the 𝐸 Stone system, the very first segmental retaining wall block in the world. So they're actually the pioneers of this system. And since then it's grown to not only Risi Stone, but a variety of other competitors worldwide. It's a huge market. So from there, they sold the Gormley plant to Unilock in 1984 and moved strictly into licensing and engineering support. We have licensees all over the world, but Unilock is our largest partner. Part of the licensing agreement is we offer engineering support as well as a variety of new products like the 𝐸2, DuraHold is a large machine place system, as well as the somewhat new Rivercrest wet cast system, as well as tools such as cross sections, wall estimator, software like the 𝐕ESPA RS package, and engineering support for designs.
So you may be wondering how Risi and Unilock work together. We at Unilock manufacture Risi Stone licensed retaining wall systems, products such as the Pisa, Sienna, Rivercrest, and DuraHold, like Eric mentioned. We have partnered together for over 35 years and offer the most proven segmental retaining wall systems on the market. The engineering and design tools provided by Risi and our ability to manufacture quality wall materials should leave you, the contractor, reassured. When we mention quality in manufacturing, Unilock goes above and beyond the American Society of Testing and Materials, ASTM standards. These standards are set for manufacturing specifications to ensure structural integrity and performance. For example, on this chart you can see that the ASTM standard for compressive strength is 2,500 psi. Unilock's standard is 5,000 psi, which is double. The ASTM standard for absorption rate is 10.5%, whereas Unilock's is 5%. What this means to you as the contractor is that you can expect strong, durable, and precise product from Unilock when building your retaining wall. Eric, let's switch gears and you can talk a little bit about when engineering is actually required.
So as far as when a design is required, it depends on your local municipality, and you'll have to call them to get a specific answer. But generally, anything over 1 meter in exposed height is classified as a designated structure. So that's 3 feet 3 inches. So what that means is you need an engineered design as well as an engineer on site to make sure that it's built in general conformity with the design. Some municipalities take that a little bit stricter and would require wall designs. There are some municipalities here for 2 feet. So again, contact your local municipality and see when you need an engineered design and when you don't. Some other circumstances that may want you to approach an engineer would be, something like a terraced wall application where it's not straightforward and you have an upper wall loading a lower wall. Fences, guardrails, anything with water, you generally want to have an engineer look at it and give you appropriate design for it. So obviously we can help with that. In Ontario, we can provide a stamped design. There's 4 full-time engineers working on staff, all licensed to practice engineering in the province of Ontario. For design from that point, you would still need to hire a third-party engineer to act as the general review engineer, and they would go on site and do periodic inspections to make sure the wall's built in general conformity with the wall design and sign off on the construction. Outside of Ontario, we can provide as little or as much design services that your local engineer would need, from anything from a 𝐕ESPA report as well as the program to design the software to a full preliminary package with AutoCAD drawings that they can then review and seal themselves.
Awesome. So you can definitely provide assistance outside of Ontario as well.
Absolutely, and we do very frequently. The better the relationship there is with the local engineer down there, the more smoothly the process is going to go.
Awesome.
So as far as wall designs and how they work, the first thing we'll talk about is gravity walls. This is not a Risi Stone rule. This is basically anything, even natural stone. For a gravity wall, you need about a 3-to-1 base to height ratio. So if you have a block that's 1 foot high, a 1 foot front to back depth like the 𝐸2 system, you can go about 3 feet high. That's total height, including the 6 inches that you have to have buried. If you have a 2 foot deep block, you can go 6 feet high. That does not account for the drainage layer that you need behind it. Any gravity wall is going to need a minimum of 1 foot of a number 57 stone or a 3/4 inch clear stone behind the wall, as well as a drainage tile, which you can see at the base of the wall here. Once you get into Geogrid reinforced systems, it's a little bit different. The design methodology that we use is the National Concrete Masonry Association design for segmental retaining walls, and their minimum base to height ratio is 60%. So on a 10-foot high wall, you need to have 6 feet of grid. The minimum grid length that you're allowed to put in, however, is 4 feet from front face of the block back. So even if you had a 4-foot high wall, you still need to put 4 feet of grid in, if grid's required. Now, that doesn't account for poor soil conditions, slopes and surcharges, seismic loading. So if I were to suggest a contractor to estimate how much grid they're going to need, I would probably shoot more towards the 70 to 80% base to height ratio.
Eric, one of the questions I get more and more on site is, how do I deal with a property line? Obviously, homeowners and property developers are trying to utilize as much space as they can. What is your suggestion on that?
So if you're tight to a property line, you're not allowed to put structural elements over a property line. Even if both property owners agree to it, that wall's going to be there for 75 years, the property owners aren't. So I've never once seen a municipality allow a structural element to cross a property line. So the simple solution is to throw more concrete at the problem. The picture on the left is actually sienna stone, so the bottom units are 925 and the top are standard 500s. This is essentially just an unsplit 500 unit. That allows us to have, almost a 3-foot block at the bottom, so you can, basically go 9 feet high as a gravity wall. That gets you substantially closer to the property line, does not account for the drainage behind the wall, and it does not account for excavation. So on a 9-foot high wall or a 10-foot high wall, you obviously can't cut vertically, so you're going to need permission to either excavate over the property line and replace that material later, or use temporary shoring. It's just a question of what's worth more to the customer, the land, or the cost of the wall going in.
Makes sense. So segueing from that, we're going to talk a little bit about using Geogrid and how to properly install it. So Geogrid, which I'm showing here, is a uniaxial grid product used to reinforce and stabilize your backfill material. This allows for a transfer of forces to a larger area, but only if installed properly. So if we take a look at the picture on the screen, you can ask yourself what's wrong with the installation, and hopefully a couple things pop out to you. Number one, the grid is not actually tensioned. So in the picture you can see it's quite floppy. What this does or doesn't do is actually doesn't stabilize at all, and it ultimately becomes useless. So the second thing is you can see that there's a void between the back of the block from the Geogrid. So the backfill material had not been brought up to level before the Geogrid was installed, and this creates the void. The third problem is that there's gapping between the grid installation sections. So there should be just touching, not overlapping, but you don't want a gap either. And then finally, there's contamination in the backfill material and either poor or little to no compaction done. Eric, when we talk about the void at the back of the block, why do you not want this?
Basically, the void behind the block, when you start putting material on top of it, is going to start stretching that grid. And these are machine-made units, and if you feel the edge of them, they can be relatively sharp. So if you have a void and you start loading material on top of it, it's going to start stretching that grid down, pulling it over this edge, and I have actually seen it rip it like a razor blade. Once that grid's ripped, it's no longer performing what it's supposed to be doing, and then you have a chance of failure. So what you could actually do on site is you not even come level. You can actually come a bit above the block, and that will allow for settlement and consolidation of the grain there behind it, so that you still stay relatively level. So I'd rather you be up a little bit higher than not.
Makes sense. So when we're talking about how to install Geogrid properly, what you're going to be doing is rolling your Geogrid out and cutting it from the roll. It is very important that you're using the specified amount of Geogrid required. So if 1.2 meters of Geogrid is required, you can't just go and use 1 meter. You need that required amount. You're going to lay your Geogrid out from the roll it backwards, making sure that there's 1 inch back from the face of your Pisa 2 for in this instance. You would take another Pisa 2 block, set it on top to secure your Geogrid, pull your Geogrid tight and tension it, and then stake it at the back to maintain the tension in the Geogrid. Next would be your backfill layer on top of the Geogrid. You start with putting it at the back, your backfill material and raking it down backwards across the geogrid. This again allows that tension to be maintained on the geogrid, which is so important. So keep in mind when installing geogrid properly is one of the ways to prevent long-term failures of a retaining wall. I guess the other major impact on long-term performance of a retaining wall would be water.
Yes. Yeah, we want to make sure we address the water every single time. Biggest cause of failure for segmental retaining walls is the injection of water. So if it's something we know about ahead of time, we can design for it with adequate additional drainage measures like blanket and chimney drains of clear stone. But if it's something that we don't know about, the more precautions you use ahead of time, like a free draining granular material, the better. In this particular application, this is a wall that failed several years ago. The backfill material, I don't know how free draining it actually was. It did have geogrid reinforcement, but it did have the wrong type of filter cloth. In fact, the wrong type of filter cloth is sometimes worse than no filter cloth at all. That all being said, this wall probably would have been fine without the introduction of water to it. You can see in the picture above it, there's a snowbank. So this is essentially a cul-de-sac where the snowplow driver just dumped the snow over top of the guardrail. And then come spring, melt, that water started melting, getting into the geogrid reinforced zone, pulling out the fine materials and creating these cavities behind the wall. It would freeze again, jack the wall out a little bit, let more water get in there, and then start flowing. There was a couple pictures where there was like cavities where you could put your arms in for where the water washed out all the material. Wow. Eventually, the water pressure just built up behind it. The hydrostatic pressure caused this thing to fail.
Explode.
In this particular application, this is a Sonoma stone product. They called us out to site. The wall was actually starting to belly on it. And you can see in the picture here, this white stuff's not effluent, it's actually ice. It was cold, so the water was draining up the face and freezing. Had this not been a segmental retaining wall with these cavities in it, so because you don't mortar it, it allows the water to seep out. If that water wasn't allowed to seep out, this wall probably would have failed before we got there. But there was some investigation on site, and on the next slide you can see what they came up with. So there's the drainage tile kind of sitting in a puddle of water and pointing up, so water runs downhill. What they ended up doing was digging a hole, turning the pipe, banging it a bit, and a chunk of ice flew out of it, and then water started firing out of it like a fire hose. So the reason we're showing you this is, you know, the wall was built right. They had the right drainage material. They had the right drainage tile behind it. The problem is you can't just put a drainage tile in there. You have to make sure it's doing what it's supposed to be doing. So either outletting through the face, it has to have a positive outlet to a catch basin. It's not just, this is my wall and I'm in charge of putting a drainage tile into it. You have to make sure that that water is going somewhere and not being stuck behind the wall.
Makes sense. So when we talk about drainage, we need to talk about proper backfill material. It needs to be imported, well-graded, free draining, maximum 8% fines, granular backfill. So this could be granular B, which I'm showing here, granular A, ASTM 57, ODOT 304. It all depends on your region. So every area has their own gradation requirements. It's very important to know what's actually required in your area. Eric, when you're designing and specifying backfill material for your designs, does it change depending on if you're using a geogrid wall versus a gravity wall?
So every gravity wall should have clear stone behind it, number 57 stone, at least that 1 foot drainage layer. Often when we're doing designs for gravity walls, we'll actually put a 45-degree wedge of clear stone behind the wall. That reduces the amount of pressure acting on the wall and increases the amount of drainage. Once you introduce geogrid reinforcement, more often than not, it's better to have the granular B or the well-graded granular material around it, because that binds with the geogrid a lot better and performs a longer-term stability. There's certain circumstances where clear stone or whatever you want to call it locally would be used in a geogrid reinforced wall. Something under 10 feet high, a water application, for example, where you want to make sure the water gets out as fast as possible, you can use a clear stone material for the entire grid zone. It just has to be designed accordingly. Obviously, the parameters of clear stone are different than granular B, so your grid lengths are going to be a little bit longer, but if it's designed for it, you can certainly do it. Certain products like Rivercrest is so small, we don't want to have a lot of compaction behind that block, so we would usually design that with like a ASTM 8 or a high performance pipe bedding.
Makes sense. So the benefits of imported granular material, a couple come to mind, but first of all, it doesn't require tedious construction of drainage layers Compaction is less dependent on moisture content, less susceptibility to long-term creep of the soil mass. There's higher shear capacity, so just overall greater strength, which actually means less geogrid is required, better drainage, and overall higher performance of your retaining wall. So we're going to look here at machine set installation. So this is any type of product, DuraHold, Sienna, Sonoma wall that can be used with a machine and a clamp.
Yeah, so a lot of people are a little scared of machine placing systems because it's not something that they've been doing for the past however long, but the point of showing you this video is to show you how fast stuff can go in. Generally, you know, with a machine installed, you can probably put the wall in 2 to 3 times faster than you could with a small hand placed system. So there's a local engineer here with 3 guys, so 1 in the crew, 1 at the pallet putting the clamp on, and then 1 at the wall steering the block in place. Can do, you know, up over 1,000 square feet a day.
That's amazing.
So that's not something that's going to happen overnight. You have to practice and get better at it. It's the way you set up your site with where the material is actually placed, so make sure you're not wasting time traveling back and forth. But finding labor is getting harder and harder. Having guys slug around 80 to 100 pound blocks all day is time consuming and tedious and hard on them. So you're relying on a machine to do all the heavy lifting, and once you get efficient at it, you can make a lot of money and get a wall installed in a shorter period of time and then move on to the next project.
Makes sense, and I think that point hits home with labor being harder and harder to find. Relying more and more on a machine is beneficial.
Yeah. Couple things about handset blocks. So there's handset blocks like 𝐸 Stone, which are shown here. 𝐸 2 are all great. You just have to make sure they're the right product for the application. So really what happened in this particular application is they designed it with a parapet wall. So the wall ended and then it extended above grade, so it was exposed on both sides. That's becoming more of a popular feature these days, especially in you know, patios in the backyard where it's fine. But what really has to be taken into account is what is the purpose of that feature? Is it aesthetics, or is it actually taking some kind of load? Generally, it can't take any load horizontally. So in this particular application, you can see the sign behind it. They just drove it back and bumped the retaining wall. And because we're talking about a block that only weighs 50 pounds, it just kind of shoved it out and over. That may have happened even if you were using Sienna stone, but really you just have to know the purpose of what you're building and what loads have to go on it. And in this particular application, they probably still could have done that, but put up a bumper curb behind it to protect it from any kind of vehicular impact. And this product here is project is still 𝐸 Stone. It was probably done in the 80s. So back when these products first came out, when Tony and Angelo first released them, there was no design methodology or guides on how to install them. And a lot of people just bought the stuff and then built walls 3.5, 4 feet high, but didn't put any drainage aggregate behind it. So on this one, you can see the slope down behind it. Water probably got in there, jacked it over a little bit, let it move, and then over time it's starting to rotate forward. So even though this is a hand placed set block, it probably would have been okay had it had the proper drainage behind it. Mm-hmm. Water is the biggest cause of failure for all types of walls.
So we go back to drainage.
Drainage.
Speaking of water, can you design around water, and can retaining walls be submerged in water?
Retaining walls can absolutely be submerged in water, provided we know about it ahead of time. So in this particular application, this is the West London Dyke. It's in the Thames River in London, Ontario. It's about 29 feet high, give or take, and it had to be designed for the 250-year flood elevation. There are some residential properties on the other side of it, and obviously they didn't want them getting washed out. So this is the DuraHold system. It actually has behind the wall face about 2 feet of ASTM8, followed by the granular B behind it. When you're talking about a water application, some things that you're probably going to have to do is increased embedment. So instead of your 6-inch minimum embedment, you're going to have to embed 10 feet. You're going to have added drainage criteria, such as drainage behind the wall face, as well as outlets through the face at the high water level and the normal water level. And it's going to result in more grid and longer lengths of grid. So as far as what we need for the design point of view, we need to know what the high water level is and what the normal water level is. And then we would go ahead and design it for the high water level in front of the wall, but then a 3-foot rapid drawdown. So we'd have about 3 feet of active hydrostatic pressure acting behind the wall in a negative aspect.
And how big is the London Dyke?
really big. This is phase 6 under construction in the video right now. Phase 7 is currently being built this year as we speak, and it's adding on another 400 meters. So it's the biggest wall I've ever designed.
Nice.
This next one is a case study for a residential subdivision in Ontario here. So this is actually showing the Sienna Smooth product. It's very similar to the Sienna Edge that's going to be available in some markets coming up. The Sienna Edge has a few different components, but from the face, it's basically going to look the same. So this is the granite blend. It's just a smooth face version of Sienna Stone with a little bit of a different height to it. So the reason we're showing you this one is because it had a bit of an interesting scenario behind it. So this was for a subdivision where they needed to put houses right behind it. Segmental retaining walls are flexible in nature. Houses generally are not flexible. You don't want them to move. So what was done here was, you can see the blue part in the cross section. So this is all poured in place low strength concrete that they poured in 3-foot lifts. You can't just pour concrete freestanding. So the black part here, which is the black or the green part here, is actually soil cells. So they used the soil cells to form the concrete, and they poured behind it. And in front of that, they just built the standard Sienna Smooth retaining wall design with grid tying into that. So it's the Sienna Stone's holding up the formwork, which is holding up the concrete, and then the house gets built on top of the concrete and won't have to move with the potential movement of the flexible Sienna Smooth retaining wall. The video playing, it just shows the extent of the wall itself, and you can see the clean lines on it. It's really meant for a modern look, which is becoming the thing right now, smooth, linear. And it's a great looking product, and hopefully it does well for everybody.
Sure. So getting Unilock involved in your retaining walls as early as possible, whether residential or commercial, allows your project to progress smoothly and with the confidence that it will last. There are 3 different ways that Unilock and Risi can help from a design aspect for your wall project. So number 1 would be helping just with product selection, so picking the right wall for the right job. For example, if it is a larger retaining wall and it does have a radius, using Sonoma stone over Sienna stone is usually a better option, just because there's tapered units in it. There's also the preliminary cross sections. This can be found on our website or Risi's website. What you would do is just select the product that you're using, the height of the wall, as well as the loading of the wall, and a ton of preliminary cross sections will be populated. This is a great starting point for any retaining wall. And then finally, there's the site-specific design packages. Risi will be able to provide you cross sections, the stamped engineered report, and face footage so that you can do your own takeoffs on the project. When you contact your territory manager about a site-specific design package, do not be surprised if we ask or try to gather as much information about the project as possible. Questions such as how close to the property line is it, if there are catch basins, trees, or buildings nearby, slopes above or below wall, types of barriers such as handrails, fences, or guardrails. This is information that Risi needs to know when they're engineering or providing cross sections. It helps pick the right product and allows them to design correctly, and then ultimately providing you with a cost-effective solution. They'll also ask you to send a complete grading plan with top of wall and bottom of wall heights, as well as spot grades around it, and this can be provided in a digital copy. Is there anything else when it comes to the full engineer report?
No, I mean, the more information that you give us, the better design and more accurate design you're going to get back. So it's just a question of how much information you need from us, whether it's a cross-section, a VESPA report, or a full design. We're here to help and do as much or as little as possible. And those case studies showed a couple dramatic circumstances. Not every retaining wall is straightforward. So if you run across a project where you're not sure what you're going to do, call your Unilock territory manager, and they can reach out to us. And we've got 50 years of experience in the office, and we can try to over 50 years of experience, and we can try to help maybe come up with a solution where you're not going to be able to put your full-length grids in. We might have an idea for you.
Awesome, and I know it sounds silly, but just remembering it, you can't reverse engineer a wall, so you need to consider the whole site at the beginning of a project and make things a lot easier moving forward. Thank you, and all the best in the upcoming season.